Hello everybody, this is Carlo again from Common Beat Music Repair here in sunny Philadelphia, Pennsylvania. Although today it's a bit rainy outside, so I guess that makes that first thing I just said a total lie. Anyways, today we're going to talk about replacing your Technics 1200 target light with an LED. This is a pretty common thing that gets done on these. A lot of people have trouble though, and I just kind of decided I want to make a little video kind of outlining the process of replacing it so that you don't go and try it yourself, put it all back together, then end up shorting out your light and having that voltage go and ruin something on your board inside. So if that sounds like fun to you, let's get started. So I got a few tools that I like to use for this particular job. And you know, your typical snips. We need some wire strippers. We're going to need some heat shrink. This is 1/16 of an inch heat shrink, and I use a hot glue gun at the very end once I have the LED installed, just to kind of hold it so it doesn't spin or move while we're working on it. So first things first, we are going to take and remove this resistor right here. This is on the switch originally, and what the deal with that resistor is that it's meant to limit the current so that on a typical filament style light bulb it won't continue to light up when this switch is turned off. Because even though this switch is technically in the shorter position right now, it wouldn't necessarily turn off that bulb. Like if I had an original one in here and this resistor wasn't in place, that thing would be dimly lit in there. So what we're going to do is, and since the LED draws a lot less current, we're just going to cut it out. We don't need it anymore. So I'm going to start by just clipping that out. I think this is 1.5, like 1500 ohms or something like that, or 1.5K, but it's not really important to know because it's not useful for what we're doing. So the next step is we got to remove this screw here. Actually, before we do that, let's install the resistor in line. So on this particular one, I've done these a lot, so I've kind of designed my little version of the circuit based around the LEDs that I use. Yours may change. What I can tell you is, and I guess I'll put it in the description. We can look at what the milliamp, or in this case, we're talking about the current. So we want to know what the current coming into this light is. I know that it's like about 20 or 21 volts. And then for the current, the reason we want to know current is because if we wanted to take, depending on what LED you buy, you want a 3mm, and then you can pick whatever color you want. I happen to be using white for this one. But if you wanted to fine-tune this, you could actually go ahead and start messing with the resistor value based on what LED you have. So what you'd need to know on your LED is what's the forward voltage and what's the current that it can take. And then you maybe want to back those numbers off a little bit because you don't want to be at the maximum rating for the LED because it'll be very hot. So let's say 80% of the value. In this case, if let's just make an example, and this is not going to be the case, but if your LED says it can take 10 milliamps of current, then maybe we'd want to go with 8. It's probably going to be higher than that, obviously, but just for the sake of this theory that we're talking about, if you wanted to fine tune it, that's the way to do it. In my case, I ended up going with a 330 ohm resistor to match this LED that I use, and you can go online and find a resistance calculator for LEDs. Just search it on Google or whatever your search engine is, and you can find it really easily. And then you can fine-tune something for your table based on whatever the LEDs you get are. You can just buy everything as one set and install it as one set. Because I do this all the time, I went and bought a bunch of different 3mm LEDs, and I also bought, I have a lot of different values of resistors here in my shop. So I kind of did some experimentation to see what kind of LED is going to give me the best visibility, because I wanted to make something that was sort of a nice upgrade for a lot of these customers' tables that come into my shop, and This personally is what I have found to be the best combination of brightness and focus of the light, because also the path that the light takes when it's shining out of this tower and across the table and across the grooves on the record, I think is very important. The original one is, it's not really focused. The LED is going to be forward facing. We're not going to put it in there upright like this. It's going to be facing out of this thing where it's its brightest and facing forward that way. So when we do that, its beam of light that comes out, whatever the shape of this cone is, your LED, if you do the look at the data sheet for it, will actually tell you what's the thing. Is it 45 degrees? Is it 60 degrees? Whatever. You can be the judge on that one. But our first thing I want to do is, like I said, I want to go ahead and install this inline resistor. The reason we need this is because most LEDs are rated like between 3 and 5 volts. And I said that the supply is 20 to 21 volts. If I just hook this up without a resistor in line to limit the current, it would burn this LED up. We'd see it get really bright for about 2 seconds, then it would blow up. So that's why we need this in line. It goes in line on our positive side of our LED. So on that side where the forward voltage is coming in and going back out through the negative side, we are going to add a resistor in line to limit the current so that you don't burn this up, and it works within what we have. So essentially that's a circuit. I wouldn't know if I would really call it a circuit. There's not switches or anything fancy. It's just essentially an inline resistor. But I think it's a simple circuit that we're dealing with here. We actually do, because we have the power source coming here. We have a switch. We have a light. And we have a resistor to limit the current. So that's a circuit if I've seen one. Anyways, for this one part, I like to clip the leads of this down. So there's about 1/4 of an inch on either side, and then before we solder both sides together, I'm going to actually cut a piece of heat shrink. This is 1/16 inch, I think I said that already. I'm going to cut it 1 inch long, because this is about 3/4 of an inch, and then we're going to have the two other sides of the wires overlapping on either end, and then I want like 1/8 of an inch on either side so that this covers the entire solder joint. So I'm just going to put this LED aside for now. I'm going to go ahead and strip this back 1/4 of an inch, and then we're going to go ahead and strip back this 1/4 of an inch. Okay. And then it's good to put some solder on this while you're doing it. It's going to make everything bond easier. You shouldn't need to use a lot of heat here, because there's not a lot of surface area to be heated up in the first place. So on my LED, on my resistor, I'm also just going to put a little bit of solder on the legs of this. We will also do that on the LED as well, but not right now, we won't. So from here, actually just going to grab a pair of tweezers so that I don't burn my hand here. We're going to take and we're going to just lightly touch that so that both sides flow. Now you can see that this resistor is attached there. I'm actually going to get you zoomed in a little bit. I feel like maybe what I've been telling you is hard to see because you're not that close. Hold on 1 sec. Sorry, I don't have the best camera system here. Okay. That's a little better. Okay. Yeah, so then I'm going to take that piece of heat shrink, slide this on first before we go ahead and attach the other side. That's going to go like this. So I'm going to make sure you can hold it as steady as you can until it cures. And then we'll just give it a tug, make sure it's not going to break apart on us. Then we'll slide our heat shrink over the entire joint, like that. And I just use a piece of lighter here, or a lighter with just to shrink the tube. You could use a heat gun here, but this is just going to do it pretty quick. It's a little more handy. Alright, so that side's done. Now, we can go ahead and take apart we have to take this screw out to get the tower out. This is a pretty small screw. It's about the size of one that would be on a set of eyeglasses. So you need a really small screwdriver. I have this cobalt one. I think I bought this little set at Lowe's if I remember. It's pretty nice. It comes with a bunch of different bits that are useful for all kinds of different electronics repairs. And it allows me to get this screw out. Sometimes these get a little bit stuck. If you have a problem, I got lucky once again. If you happen to have trouble getting it out, you can use a little bit of heat, like a heat gun or a blow dryer. Sometimes these like threads just get gummed up for whatever reason, and doing that just kind of like lets the screw expand a little, or lets the whole hole expand a little bit, so the screw's easier to get out. That's my experience. Or you could maybe take this and put it on the screw and just tap it a little bit, kind of like an impact driver works, to get it out that way. So this is the old one. We're just going to pull this up to about here, because we'll end up pulling it back down once we put the tower on. I'm just going to put this aside for now. And we are going to just chop this wire here, because we don't need this. We're going to toss this bulb out. Then for this part, you might want to take a pair of small needle nose pliers and just hold this wire while you're stripping it, because otherwise if you just try to hold it with your fingers and pull it, this wire's kind of got a slick coating on it, and it tends to want to pull through there easily. It's supposed to, because it's got to slide along a spring inside there, and they don't want the wire to chafe or rip through. So that's part of the design. They sort of picked a wire here that's got a sort of slippery coating on it. So when you're trying to hold it to strip the wire back, it's a little easier to do it the way I'm describing here. So same thing as we did on the other wires here. We're just going to twist these up, and we're going to give them a little bit of solder on their tips here. Okay. So you may have noticed that my soldering iron looks a little crappy. I actually broke the handle on my good one. I need to order a new one for that, new pencil for that one. So I'll do that eventually. Right now, this old straight in the wall Weller one will do the job. Not temperature controlled or anything, but it'll get this job done, won't it? So we're going to put that aside. We're all set with that for now. So I cut two pieces. We're going to eventually cover both of these. And then now what we want to do is figure out what's our positive, what's our negative. They didn't use different color wire here, so we don't really know which is which. It's important to know so that we put the LED in there with the correct polarity. So the easiest way to do this at this point is just to connect this. We know this is our negative side because the positive side is over here. It comes straight out and goes over. Actually, what this switch does is actually switches the negative side out, not the positive. It could have gone probably either way, but that's not the way they designed it. So I'm just going to clip one side on this over here, and then whichever one of these makes continuity, we'll know is the negative. There we go. So that's our negative, that's our positive. We got that? We're going to do that one more time. Negative. Right. Okay, so our LED. What I think is a good thing to do is to actually bend over these legs now. We want to bend them at a 90-degree angle. So we want this to go up, straight up, and then have the LED itself go forward like this. So I'm going to bend that down, and then I'll actually bend the other side down too while I'm at it. So this way you can, right now we can still see which one is the longer leg. I like to trim these separately, so first I'll do since we're going to do the negative first, I'll trim this off like that. And then before we even get started doing all that crazy stuff, I'm going to go ahead and slide a piece of heat shrink tubing over it. I cut these pieces of heat shrink about 1/2 inch, or 3/8 to 1/2 inch will work for this. And then we want to get it. I'm going to put a little bit of solder on the pins of the LED. And I'm going to grab my tweezers here just so I can kind of manipulate this thing into place here. And then we're going to go ahead and melt that solder like that. Oops. Sometimes it's hard to tell how melted it is, or not melted it is. that. I had a little wire stick up, so just use your snips and just trim off so that's clean. And then we can go ahead and do the other side. I'll trim that off now. And then I will attach my positive lead. This soldering iron does not give me the finesse of my good one, which is why I don't use these that much. This is just my backup iron if I should find myself with a... that didn't come out that good. Let's do that again. Anyways, this is just my backup iron, and I only use this like in a sort of emergency situations, or if I'm like out and I need to do a job that requires me to bring a soldering iron with me. I'll take it out into the field with me, because trying to plug in something that requires a power supply is a little bit of a pain. So this is giving me a pain. Speaking of which, I probably could use my helping hand thing, but I didn't do that today. Okay, that's good. Kind of glad I went a little bit longer on my heat shrink. Oh, speaking of which, I forgot to put it on, didn't I? Yep. Work smarter, not harder, everyone. Okay. Let's try that again. Cut this. Oh, here it is. Feeling like a dummy. I don't really rehearse for these videos, so what you see is me kind of doing it on the fly here. Trying to talk you through it. And relate the information without sounding like a total idiot. Although I feel like I'm not doing a very good job of that right now. Okay. It's probably gonna burn my finger, but I can take it. I'm tough. Alrighty. Same thing, I'm just gonna trim off the excess on there. That's not the prettiest joint, but it's strong, so we'll call it good. I'm going to just slide that heat shrink up all the way and use my lighter again to just melt it down. That's all set. I mean, if we wanted to check that beforehand, we could actually go ahead and put that in the table and just make sure that our connections are all good. So let's do that real quick just for the sake of argument. And then we'll do one more check at the end when I actually reassemble the thing. There we go. It's working. We just kind of wiggle it around, make sure our connections are all good. Looks good to me. So we'll put that back down here for now. And then when I get it all back together, we'll check it again. So our next move is putting this little cap back on here. You want to make sure the LED faces towards the screw hole here, because that's the way that the tower faces. Everything is in a line. So you can just kind of grab this and just give it a twist, and then I'll get this down inside here. And then sort of slide it. Just give it a push and a twist. And we are back together there. I'm going to put that screw back in there. Sorry. I'm going to put the screw back in. And then if you look at this, I made the LED. The LED is sticking out quite a bit. We want to get that pushed in. You don't really want it to stick out more than like a 1/16 of an inch, or else it won't get back through the hole. On the hole that this slides through on the top of the table is bigger than this actual tower piece. So, 1/16 of an inch is like the kind of max towers that you can have this sticking out. This way you'll get your brightness coming out. So at this point, I'm going to go ahead and fill this with some hot glue. Not too much. You don't want to like squirting out of there. Just enough to kind of fill it in and keep everything from moving around. Just going to scrape a little bit away with my thumbnail here. Oh, I'm going to actually go with a little more here. Okay. So there's that. That's all set. We can actually take and twist this wire up a little bit if we want to, just help it run underneath the board a little easier than trying to get both ends like that. Okay, so put that back over here and pull our table back up. Screws put back in here. Flip her back over. It's kind of easier to do this in two parts, so we're going to slide this connector underneath. Hopefully I can get it through here. I might have to, not, I'll just pull these screws out here. Underneath our pitch fader, and we're going to wrap around and go back into our connector on the board. Okay, so make sure that's all tucked in nice and tight, and then we can give it, we can turn it on, we can see that it's working. And then you can see here, there it is. Look how much brighter that is. That's pretty sweet. Definitely helps to make this thing better to see in the dark. And if we just, for the sake of argument, I'm going to go and turn off all the lights and just throw my good old trusty Herbie Hancock Future Shock record on here, and you can see what's going on. You can see now that we got a little bit more of a solid beam of light. Hopefully you can see what I'm looking at. But we can see the Q lines going by now. Makes it a whole lot easier to see what the hell we're doing in the dark. Well, I can see that from here, and I'm looking to the same screen that you are. So there you go. That's the LED circuit for the Technics 1200 as designed by moi. This is Carlo again from Common Beat Music Repair in Philadelphia, Pennsylvania. Thanks for watching. If you have any questions, please leave comments, and I will do my best to answer them for you. Thanks again.